Hello, Honors Algebra 1. It is Thursday, April 30th, the last day of April, and we are continuing on in Chapter 12, Section 4. And today we're going to talk about a special word called the discriminant. Okay, now let's first of all talk about what it is, and then I'll explain the significance of it. The discriminant of any quadratic equation is what's right here in the purple box. It is b squared minus 4ac. It's simply a number. All right, now, where do the b squared minus 4ac values come from? Well, it comes from any quadratic equation in standard form, where a is the coefficient of the squared term, b is the coefficient of the first degree term, and c is your constant. And so b squared minus 4ac, if you remember the formula we learned yesterday, that is simply the radicand, okay? It's the number under the root. And so, excuse me, the discriminant is simply going to be the number we calculate under the root. We don't include anything else, the negative b and the plus minus and the 2a. And there's something important that that number tells us. The discriminant tells us how many solutions an equation will have. It discriminates, or it points out differences in our solutions. So when we look at that number, the discriminant, sorry about that, when we look at that number, the discriminant, it can tell us if we have 2 solutions, 1 solution, or 0 solutions. So all we're really going to be doing is discriminating or finding out what, well, the discriminant will tell us how many solutions there are to the equation, not specifically what the solution is, but we're just going to describe how many solutions does it have. Now, before we go any further, let's go ahead and look at this equation down here. 0 equals x squared minus 2x minus 3. Now, we're going to also look at its related equation, y equals x squared minus 2x minus 3. And they're different in that one has a 0 and one has a y. The 0 is replaced with a y. Now let's go ahead first and let's look at the equation that's set equal to 0, and let's solve it by factoring. So I've got 0 equals, and we don't need to complete the square or use the quadratic formula. We can simply factor this, and I think you can probably see that negative 3 and positive 1 will give us the 2 binomials that FOIL to give us x squared minus 2x minus 3. So now to solve that, those 2 factors are set equal to 0, and 3 would make the first factor 0, and negative 1 would make the second factor 0. So 3, negative 1 is the solution to the equation that is set equal to 0. Now, why did I show you this equation, which is a relative? It's like a first cousin or to the other one, and we replaced the 0 with a y. Well, here is the interesting thing. If I take that equation and put it in my calculator, so what I'm going to do is I'm going to switch here, and we're going to do a new share, and I'm going to share with you the calculator. So let's look at that right now. Okay, I have put that equation in my calculator. Y equals x squared minus 2x minus 3. Now, if I hit zoom 6, that's going to give me a normal 10 by 10. I have a parabola, and we've done parabolas before, okay? It's a quadratic equation, an x squared equation, which makes it a parabola. The x squared has a positive coefficient of 1, so it opens upward. But what I want you to notice here, where does this parabola cross the x-axis? It crosses the x-axis at negative 1 and positive 3. Well, let me go back, and I'm going to share again with my iPad. Let's go back to that. And, okay, what did we get were our answers? Negative 1 and positive 3. So the solution, or the roots, remember a root is a solution, the solutions to that equation set equal to 0, and the x-intercepts when the equation is set equal to y are exactly the same. The x-intercepts were 3 and -1, and the solution to the related equation was 3 and -1. So that's important to remember, okay? And that really should make sense because the x-intercept is where y equals 0. So what I've done is I've taken this y right here, and where is y equal to 0? At the values of 3 and -1, because the x-intercepts are 3, 0, and -1, 0. It's the two locations where y is equal to 0. Okay, now let's move on and look at this chart. This is a chart talking about the discriminant values and what it means our graph will look like and how many solutions we will have. Now, let's look at the first scenario where my discriminant, remember my discriminant is b squared minus 4ac. It's just the radicand of the quadratic formula. Now, if that discriminant has a value of 0, well, how many answers will I have? I will have one answer. I'll have one solution, one real solution, okay? And the graph will touch the x-axis in one place, okay? So I have one solution if the discriminant is 0, and it's going to touch the x-axis in one place. They're going to match one solution, one x-intercept. Now let's look over here at an example. We have y equals x squared minus 6x plus 9, and let's go ahead and fill in the values. Well, b squared minus 4ac, they plugged it in. Remember, b is -6, c is 9, and a is 1. So b squared minus 4ac, they calculated it, and it's come out as 0. It's come out as a 0. So when my discriminant is 0, what's under the root is 0, I have one solution, and I have one x-intercept. They're going to match. And by the way, excuse me, if you were to use the quadratic formula for this, this equation right here, you would get x equals -b, that's 6, plus minus the root, well, we know what's under there was 0, over 2a, which is 2 times 1. And so look what I have here. I have one answer. I have 6 plus minus 0 over 2. So my answer is simply 3. So x equals 3 is the only solution. And that matches, doesn't it? My discriminant was 0. And so I only had one solution. There is no plus minus to add to the 6. So there's not going to be two answers. When I'm adding and subtracting 0, I only get the one answer, -b over 2a. Now, what if my discriminant is greater than 0? Or what if it is positive? What if it's positive? Well, if the discriminant is positive, I'm going to have two solutions. I'm going to have two real solutions. And guess how many times it's going to intersect the x-axis? It's going to intersect it 2 times. So here's an example here. Y equals -x squared minus 2x plus 2 over in the example box. And they have found the discriminant to be 12. They found the discriminant to be 12. It's a positive number. And so since it's positive, I'm going to have two solutions, and it's going to intersect the x-axis in 2 places. And that makes sense. Let me go ahead and erase right here so I can show you. But if we were to solve this equation, okay, and give an answer, what would happen is we get -b, so x equals, the opposite of b would be 2 plus minus, well, we know it's root 12 over 2 times a. Now, and look what happens. You see I have this 2 plus minus root 12. Well, we would simplify all that and everything, but still, you see there's 2 answers. There are 2 answers that would occur. So what you'll be doing is you'll be finding the discriminant, and if it's positive, you'll say there are 2 solutions, and we will, in some of the problems, show that it intersects the axis, the x-axis twice. Now, what if my discriminant value is negative, less than 0. If it's negative, I'm not going to have any real roots or no real solution, and it's not going to touch the x-axis. There will be no x-intercepts. So let's look over here. The b squared minus 4ac we see is negative 4. And so the discriminant is negative, and so there are no real solutions. And we look over here at the graph, and you can see nowhere does this graph intersect the x-axis. All right, now, if you were just to understand that a little bit better just by doing the quadratic, whoops, let me go back here. I want an erase. There we go. So if I were to write what the solution itself is, it would be negative b, 2 plus minus the root of negative 4 over 2 times 1. Okay, well, look at this. No real solution. No real solution. Okay, now I want to go ahead and tell you, and let me go ahead. You've got a chart like this in your book. There's a nice chart, and it is on page, on page 573. Page 573 is a very similar chart to the one I have. And so what we want to look at here is, let's look at a couple examples. We're going to write the value of the discriminant for these two equations and then use the value of the discriminant to decide how many different real number roots or solutions the equation has. So your answer could be 2, 1, or none. How many real number roots or solutions does it have? And so my options are going to be 2, 1, or none. All right, I'm only doing 2, but I just wanted you to get a feel for how this works. These are 2 of the even problems from homework. All righty, so here's the first one, and we want to find the discriminant, which is just a number. It's just a number. So let me do this real quickly here. I'm going to go ahead and just kind of clean up my chart just a little bit here so we can kind of see what we'll be looking for. Okay, now let's go back, and we know the discriminant is simply b squared minus 4ac. Don't put a radical sign. It's the radicand. It's just a number. Okay. Now what is b? b is negative 3. So I'm going to do negative 3 squared minus 4. A is 1. C is positive 9. So what I've got here is 9 minus 36. Well, 9 minus 36 gives me negative 27. So I would box that. That is my discriminant, okay? And it helps me discriminate by telling me what kind of answer will I have. How many real number roots will I have? Well, what is it? It is less than 1, and so there are no real roots. And so under that, I will simply put none. There are no real roots, because under the root, you're going to have a negative number. And so you can't do that. It's not a real number. The square root of negative 27 is not real. So my word none has not come through. I wrote it and it hasn't come through. That's weird. Okay, none, where are you? Well, I wrote the word none. Oh no, I've lost mine. Let me go back here. I've lost mine. Let's try it again. Let's see if it showed up this time. Sorry guys, there it is. All right, technical difficulty. Let's move on to the next one. All righty, let's go ahead and find the discriminant. B squared minus 4ac. Well, b is 5. I'm going to square that. Minus 4 times 2 times c. So I end up with 25 minus 4 times 3 is 8. 8 times negative 3 is negative 24. So I really have 25, excuse me, plus 24. And so I am getting a discriminant of 49. Excuse me, 49. I have been talking all day. Whoa, 49. Okay, now that is my discriminant. I box that. Now, how many solutions are real solutions am I going to have? Well, it is positive. Because it's positive, I'm going to have 2. Let's go back up to our chart. 2 real roots. And so I just put the number 2. Okay, when would I get a 0? If my discriminant when would I get a 1? I'm sorry, when would I get a 1 solution? If my discriminant is 0. I didn't give one of those examples, but anyway, that is when you would get, instead of none or 2, you get 1, when you get a discriminant value of 0. And I'm just peeking here at your homework. You will get some answers that have 1, at least 1. Okay, now let's go to our last page. And you're going to have a few of these for homework. Without drawing the graphic, without drawing the graph. Without drawing, let me fix this. Without drawing the graph of the original given equation, determine how many x-intercepts the parabola has and whether its vertex lies above, below, or on the x-axis. Okay, now we're going to not graph it. We're going to show our work by first showing the discriminant, okay? And we're going to figure out how many x-intercepts it has, which is going to match how many solutions the equation, the sister equation would have, or the cousin equation. Now notice this is y equals, this is a parabola. This is not 0 equals 5x minus x squared plus 6. It is not that. It is y equals, so it graphs an equation. A parabola. So let's go ahead and find the discriminant, b squared minus 4ac. All right, well, we have to be really careful here. Let's rearrange it. Y equals negative x squared plus 5x plus 6. Now, b is 5, so I'm going to have 5 squared minus 4 times negative 1 times 6. So I'm going to get 25 minus, well, 4 times negative 1 times 6 is a negative 24, and so I'm going to get 49. Okay, my discriminant is 49. Now, what does that mean? That means it has 2 solutions, right? The equation over here would have 2 solutions, and this equation over here has 2 x-intercepts. 2 x-intercepts. All right, because there's 2 solutions over here, and the discriminant says 2 solutions, there's also 2 x-intercepts. So all you'll have to do is just write the word 2. That's it, okay? But we're talking about the intercepts. It says how many x-intercepts. Okay, now this is the interesting part. Whether its vertex lies above, below, or on the x-axis. Okay. Now, here's what we have to look at. In this equation, let me make this red. Okay, in this equation set y equal to, my x squared term is negative. Well, what do you remember about that when we look at a graph? What that means is wherever this graph is, it opens downward, okay? This is a downward opening graph, okay? It's not a U, it's like a mountain. Okay, now, if it has 2 x-intercepts, think about it. If it has 2 x-intercepts, so now I'm down on my graph down here. If it were, it's asking me whether it lies above, below, or on the axis. Well, let's go below. If it's below the axis, is it going to have 2 x-intercepts? No. So it can't be below. So what's my next option? My next option is, is it on it? Okay, one of my options is it on it? Well, I meant for that to touch, okay? Well, if it's on it, if it's actually just right there touching it at one point, we would have 1 x-intercept. So it's not on it, but what is it? Let's keep going, we got one more. It is going to have to be the vertex, this is my vertex, right? The turning point is going to have to be above. It's going to have to be above. So I just write above. And those are my 2 answers, okay? So that's just logic, okay? There's nothing special about that. For it to cross the x-axis twice and be a downward parabola, it's gonna have to have the vertex above the x-axis. That's it. Okay, so come see me at Zoom if you need help on the discriminant. Discriminant discriminates or helps me determine how many solutions I have. And if it's a graph, it tells me how many x-intercepts I have. It's just a number. It's the radicand in the quadratic formula. Well, have a great day, and I'll see you at Zoom, or I will talk to you again on Monday. Boy, this week is flying by. All righty. Well, y'all have a great day.